solve for x. And here we are given the absolute value equation. We have the absolute value of 5x plus 7 equals the absolute value of 5x plus 8. So, to solve for x, notice we have an x on both sides, but this x, or both x's, are trapped by the absolute value. So the very first thing that we need to do here is remove these absolute values. So we need to remove these absolute values. So we want to think back to our definition of the absolute value. So we are given here the absolute value of 5x plus 7 is equal to the absolute value of 5x plus 8. And we know by definition of the absolute value that this can produce two possible cases. This could produce case number 1, where 5x plus 7 is equal to positive 5x plus 8. Or this can also produce the case where 5x plus 7 is equal to minus 5x plus 8. So in order to solve for x here, we need to solve each one of these cases. So case number 1, we have the positive case, 5x plus 7 is equal to positive 5x plus 8. So I just immediately removed my parentheses. So now let's solve for x. So we want to bring all of the x's to one side and all the constants to the other side. So we begin by subtracting 5x from both sides of the equation. And let's also go ahead and we'll subtract 7 from both sides of this equation. So we can see minus 5x plus 5x cancels itself out to 0 on both sides. 7 minus 7 cancels itself out to 0. So notice here on the left-hand side, we have 0. 0 is equal to 1. Does 0 ever equal 1? No, this is a contradiction. So put two arrows facing each other to say this is a contradiction. And we know this is a contradiction because 0 is never ever equal to 1. So we can make the conclusion here that there's no solution with case 1. But this doesn't mean that there's no solution to the whole absolute value equation. It just means that there's no solution to case 1. So with that being said, let's think about case 2, where we have 5x plus 7 is equal to minus 5x plus 8. And let's give ourselves plenty of room here. So again, we need to solve for x. Now, to get us started, the first thing we need to do is distribute this negative through to both terms on the right-hand side. So we are left here with 5x plus 7 is equal to negative 5x minus 8. Now again, just like with case 1, we want to bring all of the variables to one side, all of the constants to the other side. So I'm going to bring all of the variables to the left-hand side. So I'm adding 5x to both sides of this equation. And I'm going to go ahead and bring all of the constants to the right-hand side. So I'll subtract 7 from both sides of this equation. And so we can simplify. We see here that the minus 5x plus 5x cancels to 0 on the right-hand side, and that the 7 minus 7 cancels itself out to 0 on the left-hand side. So we have 5x plus 5x is 10x, and this is now equal to minus 8 minus 7 is negative 15. Beautiful. Now, to isolate x, let's now go ahead and divide both sides of this equation by 10. And we see 10 divided by 10 cancels itself out to 1. And so we're left here with x is equal to negative 15 tenths. But we can simplify that further. We know that these have a common factor of 5. We can rewrite 15 as 5 times negative 3. And we can rewrite 10 as 5 times 2. And look at that. these 5's will cancel each other right out to 1, leaving us with -3/2. Woohoo! So this is leaving us with a viable solution, the solution that x is equal to -3/2. And so this is the only beautiful final answer.